Welcome to our second meeting. We had a lot more attendees, so I'm guessing more people might shuffle in. I hope more people will shuffle in as we get going here. This is, and thanks again to Rachel for helping out with the logistics and getting us some presenters. We have Eric Wu and one more time. Anirban.
No.
Okay, I'll let you. Yes, it's up here. Anirban Rahut. Okay, sorry about that. Yeah. So these gentlemen are going to be presenting, and as well, Clint is going to be presenting. A lot of .conf stuff, so that happened a couple of weeks ago. I was primary on call, so otherwise I would have drove to Vegas to be able to go. But so be it. Life is operations person. So again, we're going to be meeting monthly, God willing. Going forward, we will not be meeting next month. We'll start back up again in January. So spread the word. You know, this is going to be a regular thing. I know you guys are meeting down there. I don't know how regularly you're meeting, but hopefully, you know, we can, you know, get things going and build up a Splunk community, because, you know, as I said in our last meeting, when you're out on an island, when it comes to Splunk and it's not your full-time job, it's a little daunting, you know, understanding how you can extend the platform. So that's kind of what I want to be able to do with this user group, is empower users, administrators, data engineers, how to leverage certain aspects of the tool to make their investment more worthwhile. So, one other thing is, I live 100 miles away. So, and Rachel and I discussed this. I'm going to be keeping the group going, but I'm looking for people to help organize and manage this user group going forward. I will not be doing that. I already manage a PowerShell user group that has 3 locations, and I have 3 kids under the age of 7, so I'm pretty taxed when it comes to time. So, but until we can get people who can volunteer and help out, I will be here to keep it going, because I start user groups because I want a user group, and crap, you know, here, I'll go start it and get it going. So that's my objective here. So without further ado, I'll hand it over. Eric, who wants to go first? Eric Wu is going to go ahead and get started. And again, this is streamed on YouTube. We updated the Meetup.com link, and it is a legitimate YouTube channel now. So this meeting and all subsequent meetings through Google Hangouts will be hosted on YouTube. So without further ado, go ahead, Eric. Thank you.
Yay!
You know, they have an applause thing in Hangouts.
Oh, yeah. So I wanted to ask a quick question. I'm Eric again, or Iwu. Who here is already familiar with search head clustering, like was that conf, or the kind of predecessor feature search head pooling? Is anyone here already familiar with them? A little bit? Okay, so a little bit, but not everyone. So, yeah. I'll get into that in the talk. So I'm Iwu. This is Anirban. Mustafa is not here right now. He also gave this talk with us. He was the PM that worked on this feature. So basically, how do you... Yeah, disclaimer, don't sue us. Okay, so quick overview of what we're going to talk about. The beginning of this presentation is just high-level information. That's why I wanted to ask about if anyone's already familiar with any of the search head scale-out technologies. Well, I'll talk a little bit through Mustafa's slides about the motivations behind search head clustering, why we built the feature, and kind of what the advantages are. And then I'll hand it off to Anirban, who will talk about some of the magic in the infrastructure, and then he'll hand it back to me for some of the simpler use cases. So the motivation behind search head clustering is basically highly available and scale out, high availability and scale out at the search head tier. So quick overview if anyone's not already familiar. You know, in Splunk we have search heads. They show the UI. You know, Splunk Web with, like, you know, your search bar and like, user results picker, field picker, and these are your results here. So that's all driven off your search head. The These guys are the ones that are responsible for talking to your indexers, which do the heavy lifting in terms of data processing and making the information searchable. The forwarders, you know, you might have like 1,000 of these guys or 10,000 of them or whatever. These do send the information there. So all of this, the talk, everything we talk about today is going to be focused on this tier. How do you provide resilience against node failures at this tier? How do you scale out when, you know, the number of users that you're serving starts to grow, or you want to, you know, you have more search head intensive work that has a lot of dashboards driving searches and blah, blah, blah. So that's the gist of it. So search and clustering addresses scaling at this level. And the main business benefits are to using search and clustering versus not using it are basically you can scale out horizontally. So as you add more users or more data and have a higher search load, if you happen to be performance limited at the search head level, you can scale out easily. You can expand the number of search heads in your deployment without having to add a lot more rigging. You could just say, add member to my search head cluster. You have a consistent user experience. So unlike a situation where you might manage your configurations in your own bespoke way, say in source control, if you're using search head clustering with a group of search heads all working together, you'll have a consistent user interface and search experience across all of those nodes automatically. And then the last two bullet points are basically manageability aspects, I guess you could think of it. Always on search services, kind of a PM way of saying, if a node crashes, you can still search. You still have a UI. We have a system that lets you tolerate, you know, n node failures. And then easy to add apps means we provide a centralized mechanism for deploying new configurations to your search head cluster. So you can kind of manipulate the cluster as one entity. You don't have to repeat some action n number of times for your n search heads in your cluster. So lots of business benefits. So background here for anyone, for the folks in the room who've used search head pooling. So search head pooling was a kind of earlier version of this kind of feature, except we built it a little differently. Instead of in-house technology, we leveraged NFS. So to provide a shared area where all the configurations and search state, running search state could be shared across many nodes, we relied on the user or the administrator deploying an NFS server. So that, yeah, it's incredibly popular. It actually does work for some people, but not for most, because NFS is a pretty finicky technology to use, and it doesn't, it's not intuitive for a lot of people. So the main, and of course there are certain technical, purely technical limitations to technology. It doesn't work well over a WAN. You need like a very low latency LAN-like environment for NFS to perform well. It's a single point of failure unless you pay for a scale-out NFS-based solution. And it can be pretty difficult to understand the performance characteristics of an NFS server. So for anyone who's already familiar with search head pooling, you're probably already familiar with these challenges. So the main benefit of search head clustering is we don't use NFS. And we use local storage for all of this state and take care of copying it around within the search head cluster automatically. Also, you don't need to buy any special dedicated hardware to run your storage, like you don't have to buy a NetApp box or an Isilon box or an EMC box or anything crazy like that. You can just use commodity hardware for your search heads as you would normally if they weren't clustered. Oh, deprecated. So search head pooling is deprecated. Though on Windows, support for search head clustering on Windows is still in flight. We're still kind of validating different configurations. So if you're on Windows, you're probably still going to be using search head pooling for now. So very quickly, design goals were kind of alluded to in the previous slide. For search head clustering, we wanted to avoid a single point of failure in the infrastructure. We wanted to be able to provide a simple way to have a consistent configuration across all search heads. So one set of views for roster, a captain gets gets elected democratically. Basically, one node gets chosen out of the group to perform special functions, and then from then on, everything gets copied around automatically. That's the gist of it. We'll go into more detail as the talk goes on. I'll hand it off to Anirban now.
Thanks, Ibu. Yeah, so before I go into my section, so myself, Anirban, have been at Splunk 2 years now, almost 2 years, and primarily...
Sorry, Anirban, can you share the desktop again? There was a hiccup.
Okay.
Streaming.
So, exit show and
No.
somewhere on the...
And the widget here. Sorry.
Oh yeah, there's
This is the Hangout app.
Every meeting I'm in, whatever technology is used for sharing the screen ultimately has these sorts of technical
sit in the
challenges.
back, Liz. It's your magnetic field.
Are you in the Hangout through Firefox or Chrome?
I think he's in it.
Yeah, this
okay,
is
it.
fine,
Yeah,
yes.
there you go.
Yeah, desktop.
There you go.
So it got unshared or something? Yeah.
So just
Yeah,
minimize that.
yeah, this one is
Okay.
fine. Okay, where were we? Yeah, we reached... Yeah, so I was just saying that my primary background has been in search when it comes to Splunk, and prior to that have worked on different other things, nothing related to distributed systems, so it's been quite a learning experience. Ivu left off on the high level, and what we'll do in the next few sections is basically start to basically drill down into some of these implementation decisions and how we went about designing the various pieces and explain it. You can also look at the docs. So when we presented in .conf, we did not have the docs out at that time, and now we have reasonably good docs out for 6.2, and I highly recommend that anybody who is trying to play with search at clustering first goes and looks at some of those deployment docs, and I think they give step-by-step recommendations on how to basically bring up your cluster. Anyway, so Ivu talked about that we dynamically elect one guy as the captain. I'll go into that processes and methodology more later, but first step that you need to do about the cluster is you need to basically collate all these members into that cluster. And the way you do it is through one distinguished node called the captain. Now, captain is not a terminology that is very commonly used, but we were forced to use that terminology because we already have 2 or 3 examples of the term master being used in Splunk. Like we have the cluster master for those who are familiar with index clustering, and then there is the license master. So we had no choice but to, in order to avoid confusion, we had to choose something else, and therefore we converged on captain and members. And so you basically bring up one node and you decide this is going to be my captain, first captain, and then you bring up other members and you configure them for search at clustering. So there is a little bit of basic configuration. Go ahead.
Sorry. You're sharing the presenter view. So let's, I don't know if you want to share the presenter view.
Hold on, I'm a PM, so I'm an expert at this.
So go back to the screen share. Yeah,
No,
click
back
on
to
that,
Infinity. Oh my god.
and then
Uh,
that's fine.
Whoa.
Okay, so
Go back to the screen share.
They all look
And
very
then-
concerned.
Just the app or the screen that you want.
Well, so it's still going to go into presenter view. So what you have to do is you have to come in here and you have to say, I want to do a slideshow, but I want to do a mirror show.
It's the man.
I told you, I'm a PM. I can solve this.
Keynote. This is.
Yeah, so let's go back to screen share, and then let's share this, and then let's start that, and then let's do.
And I can write code too.
Awesome, awesome, Clint. Okay, so you do a little bit of configuration on these members, and there's the server.com where most of these configurations end up, and then you bring up the members. But at this point, all these, the captain and the members are just running as standalone Splunkdies, and they have not been grouped together into a cluster. We need to do that. and that is the process we call bootstrapping. And so we go to the captain and say, add all these members as your first initial configuration. And then what the captain does is, okay, these are the IP addresses or the URIs of all these members. I will first ping them to see if they're available. And once the captain has successfully done that, it will send that configuration to each of these members. So the configuration will go and it will get stored in persistent storage. The members will reply back. Now everybody is aware of the golden configuration in the cluster. Once that acknowledgement comes back, captain will start its heartbeats to these members. And the heartbeat is a way of establishing authority on the cluster. You're saying, I am the boss right now, and I'm going to direct you going forward. And of course, failures will happen, and we'll talk how we recover from failures later. But as long as the heartbeats are going through, there is authority in the cluster, and the members know that there is authority, and they recognize the captain.
What's the requirements on proximity to the cluster nodes? Do they have to be on the same subnet? Or
So you have to have reasonable latency between these nodes. It cannot be like the captain is in San Francisco, and if it is in your different geographical data center, you need to make sure that
one or two hops in a same.
Yeah, so that is fine. As in, we are internally we have performance engineering which is doing all this testing. So as long as it's reasonable, it's fine.
What's reasonable latency? Is it under 400 milliseconds?
Way under 400.
Oh yeah, it has to be.
Like
I was actually asked this
under
today.
5?
Good question.
Like you should be on a layer. They should all be on a layer together. One site.
Do you know how much JSON is going to?
How bad the latency was in Zeus? I don't know. I mean,
I think he will introduce up to 100 or 200.
Are there any thresholds you can
Yes,
Yeah.
yes,
make it bump it up a little more?
yeah, you can tweak the thresholds.
but then you'd be in untested territory. So if you want to run on like a configuration we've tested in QA, you should probably stick to lower latency environments.
Keep in mind, you're going to have a long path type problem as well, right? So higher latency, standard TCP windowing sizes, you're going to have a really hard time moving large amounts of data over long path pipe. So low latency is absolutely critical for TCP-based systems to move data quickly, unless you want to go do a bunch of kernel tweaking, in which case then you're in a whole other land.
Yeah. So the first thing that will happen after the authority has been established is that these members will join the cluster on the captain. They will bring in their local information, and this process is called node joining, something that happens in index clustering also. When you bring up lots of peers on the index cluster, they have to join the cluster master. That process is called node joining or registration. When these members are joining, they are bringing in their local information. The captain is kind of building a map of the entire cluster. Okay, who has what and who is doing what at this point in time, and then once that map is built up, then basically the cluster starts normal functioning. This is your first cluster, but it doesn't have to stay that way. You can obviously you want to horizontally scale your cluster, or you want to shrink it. So there are convenient CLI commands that you can use to basically add nodes or remove nodes from the cluster. The next key piece of search head clustering is basically how we do job scheduling, and this is different, very different from what used to happen in search head pooling. In search head pooling, the typical practice, and Ivu is obviously much better at this than me, but we used to advise people to have a separate job server, and the job server's functionality would be to basically look at the scheduled searches, and that's the only node which would be the search head for all your scheduled searches, and the rest of the nodes would typically be your ad hoc search heads. In search head clustering, we basically have the captain pick up that responsibility. And captain basically will be the job scheduler and the single job scheduler in the cluster. Now, what is the use case? You are obviously horizontally scaling your cluster. You want more dashboards. You want more alerts. You want to bring in many more users. That's the promise of search head clustering, right? There's no other reason why you would be fundamentally using it than a single search head. So, and the scheduler is what delivers to that promise. So as I said, again, going back to the anatomy of the cluster, there's the captain, there are the members, and the scheduler, which is the clock, is only running on the captain. And the scheduler is a thread that happens in every Splunk D. You bring up a Splunk D, you will see that the scheduler is running. But what we do in search head clustering is we squelch the scheduler on everybody else, and we only let the captain be the scheduler. And as I said, this eliminates any need for a separate job server. And the captain can do a much better job than a job server because it can use the rest of the members, and it uses a load-based heuristic. So all these members will tell the captain, okay, this is my current load of search load that I'm seeing, and those things are coming over heartbeat to the captain. So captain knows which is lightly loaded, which is heavily loaded, and it can make a much more intelligent decision. So let's say the heuristic was, okay, the least loaded server, and at this point, this scheduled search that is supposed to run is delegated to this first member, because that guy was the least loaded at this point in time. Sooner or later, a different search 2 will go to a different member, because the load on this guy will bump up, and then something else will become the least loaded, and we'll dispatch the job to that one. We'll get the acknowledgements back when the job completes. Those can be successes or failure. And one thing we do, we try to be a little smart about it. How valuable it is, I don't know. But in case of a failure, in case of a search failure, and the captain knows that there is a failure, it will make one more reattempt to run that job again on a different node. But if you have a failure that is a systematic failure, that is something fundamentally wrong, that's not going to help you too much. This can only work if that node, specific node, had a problem which caused a problem in your search. But we just added it just in case. The captain can actually delegate jobs to itself. And this is a key difference between search head clustering and index clustering. And let me explain that a little bit more. So just as a show of hands, how many of you have know about index clustering? Okay, so that's good. So in index clustering, we have a cluster master and we have the peers, right? But the cluster master is just on the control path. It is not getting any replicas. It doesn't do any useful work. It is only managing these peers and the replication between these peer nodes. In search head clustering, because we have dynamic captain election, eventually the captain can change and be any other member. So it has to be one of the members itself, and just by the corollary of that, it means that the captain is fully capable of functioning as a member. It can be both on the control path, it can be also on the data path. And when I say data path, what I mean that it can run searches, it can have search replication activity that is happening to it or from it. Now that's a good thing, but for some enterprises that might actually not be a good thing, because what they would like is that the captain's amount of activity the captain is doing is contained, right? Because you don't want, you are a little concerned that the captain's memory or CPU usage should be contained, and there are knobs that we have in our config files to basically make sure that you can make the captain behave just like a control plane guy and not like a data plane guy. So admins are very interested in onboarding more and more users. And how do we do that in search head clustering? What we do is we advise you to put a load balancer in front of the search head cluster, and you can use the standard load balancing heuristics, and the user sessions will be distributed across the searchit cluster. We also assume that you have sticky sessions so that the sessions of the user are not switching rampantly, and so that's always a good thing. Yeah. So some of these I've already talked about, but let's just go into some of the details of the scheduler. So there are two features in Splunkd which started in 5.0, and these are called report acceleration and data model acceleration. Data model acceleration came in 6.0, report acceleration came in 5.0. So these features essentially let you run your searches faster. And the way they help you run searches faster is by building some kind of cached search results on the indexers. So you have a saved search and you want to use that saved search again, but we have already pre-cached that result, so we can basically populate the dashboards faster. So those searches that are populating those results, intermediate results or results, whatever you call them, are actually triggered by the scheduler. So in searchit clustering, we got to basically take care of all that, and we do manage all those things for you. As in, we'll look at what are the report acceleration searches or data model acceleration searches, and every 10 minutes we will basically schedule them across the cluster so that your summaries get updated. We'll take care of real-time schedule searches, because real-time schedule searches are a little tricky. They run only one instance across the cluster, and we'll make sure that they are going to a proper instance and only one of them is ever run. And if that fails, then we'll basically trigger another copy of that real-time schedule search. Auto failover is what happens when the captain fails. When the captain fails, someone else becomes the captain, and that new captain starts becoming the scheduler. We have a setting called captain is ad hoc search head. This is, again, you will find this in the docs, but what it does is what I was describing before. It makes the captain behave just like an ad hoc search head, and it will not delegate scheduled searches to itself, and therefore thereby it will reduce its own basically CPU usage and memory usage. Captain will basically manage the alerts across the cluster, because typically the way alerting happens is it happens under the auspices of a schedule search. So we basically first delegate the schedule search to some node, and when that schedule search finishes, then we check, okay, is there any alerting criteria that just got triggered? So based on that, we trigger the alert, but we also send to the captain some basic information about the alert so that the captain can basically manage the alerts globally. And so alerting and suppression is managed by the captain. Okay, away from the scheduler, I want to now talk about one of the promises of searchit clustering, which is high availability. How much more time do we have, by the way? Oh, is it?
Yeah, it's not like we're not counting down.
Okay, that's.
Relax, it's all good.
Yeah, so high availability is one of the goals of searchit clustering. So that is basically you want to be tolerant to node failures. But just so we will replicate, but the key question is, what are we going to replicate? As in, what is the key information in a search that needs to be replicated? So that's why I want to first describe how search happens in Splunk. And most of you are probably already familiar with this, that Splunk is a MapReduce framework, right? So we have our indexing tier where all the data resides. We have the search head, which is basically initiating all the searches. So a very common search would be something like source type is access combined, and you are doing a stats count by client IP. So client IP is the group by field, and you're trying to get the statistics of the count per IP address. Now, it will get broken down by the search head into a map and a reduce job. So it's map reduce, and the map will happen on the indexer, the reduce will happen on the search head. Once the map completes, the results will be streamed to the search head, and then finally it will be stored in a directory. And this green directory is actually called the dispatch directory. Many of you may have heard of it, dispatch directory, or a SID, or a search artifact. There are various terminologies that we use in Splunk for this directory. But when a dashboard is loading, you are in the UI and you are accessing a dashboard, you are looking at a pie chart. This is the directory where the results are stored, and that is where it's reading from. So if we have to be tolerant to node failures, we cannot let this guy reside on a single node. That would not be tolerant to node failures at all. So we have to replicate it. So that is the key aspect of high availability. How we make the results highly available is by proactively basically replicating the contents of this directory to multiple nodes. So yeah, so the dispatch directory needs to be replicated. Now, just like in job scheduling, again, the captain takes on this responsibility that, okay, I have to replicate the dispatch directory, and the user or the admin has told me that he wants a replication factor of 3. So a replication factor of 3 would mean that there is the directory that happened from the results of the search, but I need to bring up 2 extra copies of that directory. So that's how the replication factor will be 3, and the policy will be met. So the captain has to basically orchestrate the replication. So the way it happens is pretty intuitive, and probably you guys have already figured it out by now. So the origin is the node where the search ran and the dispatch directory was created. Captain sends replicate requests after identifying other nodes where the replication should go to. These replicas are picked randomly from the nodes in the cluster. So because we pick randomly, the expectation is that the search directories should get uniformly distributed across the cluster. And this is also very similar to what index clustering also does. When index clustering replicates buckets, they use randomization to spread it around. So yeah, so replication actions happen. Success and failure are basically acknowledged to the captain. The captain, after getting the successes, knows that the replication policy is met, and we have reached a good state on this search directory. But in the future, this node can go down. One of the 3 nodes can go down, and that's where the replication policy will be violated, and we need to recover from it. The way we recover from it is when a node goes down, the captain is constantly checking the policy for all the search results. Okay, am I at 3? Am I at 3? As soon as a node goes down, it figures out that it's no more at 3, it is at 2. So then it basically will trigger certain actions to basically let the replication factor go back to 3. So this process is called fix-ups, a terminology again that has been borrowed from index clustering, but this is what keeps us in good shape. One thing I do want to mention is that we currently do not have a complete story on disaster recovery. And so what is disaster recovery? Disaster recovery means that, okay, you have a site in San Francisco, you have a site in New York, and everything that is in San Francisco should at least have 1 copy in New York, so that if San Francisco goes down, New York should be able to come up and it should function as a full site, right? So we don't have the multi-site story complete, but in the next release of Splunk, we are planning to address it.
You mean above and beyond just simple index replication over to the other site? For
This-
artifacts.
And not just the index data,
Oh,
but the search
for the
artifact.
search artifacts.
Yes. So in this, whatever we are talking about, remember Ivo mentioned that we are not talking about this layer at all. We are only talking about how do we get high availability and future DR on this search head layer. Search head layer is where the search results finally reside. Indexer is where your data resides.
A concrete example of where this might matter is because most search results, if they don't take long to compute, the availability isn't that important. But it's not that uncommon, for example, for people to have like a job they run once at midnight. It takes 3 hours to run and computes data over the last day or something. And ensuring availability of those artifacts is kind of where we're still working on the multi-site disaster recovery story, where it's more important that if you lose a whole site, you don't want to lose a day's worth of computation. That's where this might matter.
So, and just going back to the artifact replication, the most common replication factor, whatever we ship by default, is a replication factor of 3. This is also what Hadoop uses. So people who are familiar with Hadoop know that, yeah, the golden replication factor is 3. Typically, admins don't change it very often. So we also use 3, but 3 is not going to get you to all the nodes in the search head cluster. So you have a search head cluster with, say, 5 members, and if you have a replication factor of 3, okay, it reached these 2 guys, but it did not, the search directory did not go here, but your dashboard that you are accessing from, so you are a user and you are accessing this dashboard, which basically, let's say you are accessing on this node. How are we going to service that dashboard when this search directory never reached here? So that is where we basically lean on another technology called artifact proxying. And what proxying is a terminology that is commonly used in HTTP and all that. So what we do is when a HTTP request comes on this search head, so this is search head 012, and the artifact is not present here, this guy knows, and there is a whole mechanism of how it knows that the artifact is present on 0, 1, and 3. So because it keeps some information, the captain keeps telling it that, okay, this artifact is present on 0, 1, and 3 now. So because of that table that it maintains, when it doesn't have it locally, it can still issue a proxy request to a different search head member and still service that request for you. And that is what we call artifact proxying. Proxying happens at the REST layer, and the way the table is kept up to date on all the search heads is basically by the captain keeping on sending logs to all the members. Okay, these are a new set of search directories that have appeared in the cluster. They are present on these nodes. So that's called what we call the artifact location log, and it's going to all these members, on a periodic basis. We also have our authentication in search head clustering, which is cluster aware. So let's say that you are a user and you were sitting behind a load balancer, and you were accessing. So this is a load balancer, and you were accessing this dashboard. And you initially the load balancer had pointed you to this node, and you were happily accessing the dashboard because it was local. But now this node failed, and your load balancer, or due to some interruptions, it basically sent you to a different node. You will not need to re-authenticate. The way we have authentication built in search head clustering is that it is cluster aware, and we will immediately, with very little interruption, you will be able to get the artifacts back. So we have taken care of authentication for you on the cluster basis. ad hoc searches and scheduled searches, there is a difference. If you are if you have heard this term, this slide is not for you. But for those who have not heard of the term ad hoc searches, when you go to the search UI and type something, that is called an ad hoc search because it's not running on a regular basis. But when you save a search as a report and schedule that search every 30 minutes or every midnight, that is a scheduled search. So that is run by the Splunk itself on a periodic basis. This is something that the user is triggering on its own. So we basically discussed this, but we find very little value in in delivering high availability for these searches because, okay, so the machine failed, but as soon as you went to a different machine, you can run the search again. And these are typically very short-lived searches, so there is not huge value in basically doing having a HA solution for those. So what we don't do is we do not replicate these searches, but we still allow you to proxy. So even if you ran an ad hoc search on this node, let's say you are running a real-time search and you opened another browser session and you went to a different node, this ad hoc search will never replicate to any other nodes, but you still will be able to access it across the cluster through artifact proxying. So proxying has multiple advantages in search at clustering. Maybe too much detail, I'll skip it. Reaping of search artifacts. Reaping is the process where basically search artifacts get deleted on a periodic basis when the TTL expires. And this has to be also centrally managed in search at clustering, and the captain, again, the usual suspect, does all the heavy lifting. Now maybe I'll go to probably the section that is a little bit interesting and less detailed. This is the auto failover and the high availability and captain election. So Ivo already talked about the design goals, right? We didn't want a single point of failure. We wanted continuous uptime. We wanted consistent user experience. So how did we achieve, just to relate to the previous slides? So a consistent user experience was achieved because we proxy across the cluster. So you can access searches just like you are basically agnostic to the node. You go on any node, you will be able to see the dashboard. And no single point of failure and continuous uptime you get through dynamic captain election and auto failover. So we used something from Stanford that came out recently, like a couple of years back. It's called the Raft Consensus Protocol, and those who are interested can go look for that paper. And basically, we borrowed the code from Stanford, made it Splunky, and basically put it in our release. And that's what is the basic technology that gives us high availability. So the key aspect of high availability is a dynamic captain election, and we got to do it. So how do we do it? So there is a captain currently, and the captain I talked about that as long as heartbeats are going to the node, the authority is established and there is no problem in the cluster. So let's say the first set of heartbeats went into all these nodes, and S1 is the current captain. Everything is fine. Let's say the next set of heartbeats also go through. S2, S3, S4, and S5 all know that S1 is the captain, so they're fine. There's no problem. Let's say the captain goes down. What happens? We have to recover from this state, and the way we recover is we start some timers on the rest of the nodes, S2, S3, S4, and S5, and we randomize these timers. So each of them is waiting for a different amount of time. Okay, I'll wait for 1 second. The other guy will wait for 1 minute 30. Sorry, I will wait for 1 minute. The other guy will wait for 1 minute 30 seconds. Some will wait for 1 minute 45 seconds. It's randomized. So the guy that is the quickest will wake up from that timer, and he will basically then say, okay, I want to now become the captain because I don't see a captain, so my next option is let me try to become the captain. And he will send some messages to the rest of the members Then if the rest of the members acknowledge that request, then S4 will know that he's the new captain. So basically he establishes his authority, and he also tries to ping the the old captain, but that message is not going anywhere. So but anyway, we now have S4 as the new captain, and so we have reached a good state where basically we can now think about high availability, because the captain is an essential state for high availability.
Is there any information about how long this would tend to take in different environments? I'm not in docs anymore, so I have no idea if this is in docs or not.
So we base this. So I talked about this timer that is the central piece of this. How long it will take depends on how long this timer is run for. So, and that is also called our auto failover timeout or whatever. So by default configuration, we have set it at 1 minute, because we could have set it very low, but then there would be enterprises where the network is slow and things would not work okay. So we want, in our first release, we wanted to be a little conservative, so we said, okay, 60 seconds is our auto failover time. So what that means is the timers will range from 60 seconds to 120 seconds. So 1 minute to 2 minutes, and so 2 minutes is the maximum amount of time that it should take for a new captain.
For the election,
yeah.
And for the transfer of all of that information, that's the part.
That is very quick. That is immediately after a new captain is elected, the other guys will register to it, and that should typically take less than 5 to 10 seconds. So you can think like between 2 minute 30 seconds, you should have the cluster functioning again.
As long as you have enough RAM.
Okay.
Yes.
Yeah.
Hopefully we're providing guidance.
Yeah.
That.
Yeah, we have scaling guidelines.
If the cluster gets split for some reason, let's say 1 through 3 know about each other and 4 and 5 know about each other for 5 minutes, so we end up with 2 captains, and then the network gets restored. What happens then?
Yeah, so the thing is, the way Raft protocol works, you can never have 2 captains, because captaincy is determined by majority of the cluster. So you have a 3 and a 2, so the 2 guys will never be able to elect any captain among themselves. The other 3 will be lucky, and there will be 1 guy who will become the captain. So the 3-node cluster will function, the 2-node cluster will be degraded.
So you'll still be able to run ad hoc searches and look at the UI of the 2-node cluster, but there won't be any alerts firing or scheduled searches running on that sub-cluster.
And you'll talk about the configuration aspect of it. Yeah. So by the way, that's a very good question. And so what we recommend is, if you have geographically separated data centers, then at least make sure that you have a little bit more nodes on your primary cluster. So San Francisco is your primary data center, then at least keep 1 or 2 more extra nodes than the New York data center. What else? Yeah, so I talked about this new captain got elected, and then Rachel had this question: what happens after that? That's the complete story on auto failover. And so what happens after that is this new captain gets elected. These guys, because of the voting that had happened previously, know that this guy is the captain, and their natural instinct is just like when the first cluster was set up, they all joined and registered. So they now know there's a new captain. They will register with all their local stuff. And what is the local stuff? The artifacts they have currently on this, the alerts that fired on them, the search load that they are seeing at this point in time, and all the jobs that are currently running on them. These might be ad hoc jobs or scheduled jobs. They will, okay, captain, this is the entire story that I have to right now. You basically register it, and the captain will again do the same thing that it did initially. It will build all the maps, in-memory data structures, and then the cluster will start operating again. So that's pretty much it. I know it's a little bit very detail-oriented, and but if you have any questions, we'll also take questions at the end after he was talking about configurations.
Yeah, so home stretch, this should be a little bit shorter because this component is simpler. So I'm just going to talk about configuration files specifically under search and clustering. So for people who aren't, anyone who's not already familiar, Splunk stores a lot of different customizations, essentially in plain text files that live inside of Splunk Home. And the most common ones typically just look like, you know, like there'll be like a name, like my report. This is what the file that contains your reports, your saved searches looks like. It's called savesearches.com. There's like a bracketed stanza for every report, and then there'll be like, you say, oh, this is the search to run. X equals food or something, right? So I'm just going to talk about what happens to these files under search and clustering. So anyway, back to this first slide. So configuration files store a variety of different customizations to the product. I think the most visible examples are reports and dashboards. So when a user saves a search like this for later reuse, or like say adds a panel to a dashboard, that ends up getting written to disk. So that, you know, obviously, if you shut down Splunk and restart it, we still have the dashboard that you created. But we also use the same basic mechanism for saving other kinds of customizations. This includes, I guess we call it late binding schema or search time knowledge, right? So field extractions, macros, event types, stuff you use, ways that you enrich the data you've indexed, but at search time. But it runs all the way from those kind of middle tier kind of customizations all the way down to like super basic. What's the port that Splunk listens on? Are you forwarding data to a forwarding tier? Are you accepting data from forwarders? Have you set up some centralized authentication mechanism like LDAP? Anyway, a whole slew of things that are all documented. But the question is basically, what are we doing with all this stuff under search and clustering? Because if you customize, say, a dashboard in one search head, that isn't, you know, without search and clustering or without any other mechanism, that isn't going to be reflected on other nodes in the system. So the goal here is to make any of these kinds of changes that can happen through the product to these files be consistent across the cluster. So if a user creates a field extraction to be run on one of their searches on one node, then later uses a different node, that field extraction will apply there as well. So before I talk about how we achieve this consistency, I need to say there's with regard to this system, there's two general kinds of changes you can make, two kind of categories, and they're handled differently. So the first category of change are customizations you make through the UI or the CLI or the REST API that change how the product looks, how the user interface looks, or change how searches behave. So search and UI configurations. So these include saving a report, modifying dashboards, creating field extractions, macros, tags, et cetera, et cetera. That's the first category. The second category is everything else. Typically, these would be system configurations. And so, like I mentioned earlier, this would include forwarding and receiving data, authentication, authorization, and there's other things too, like logger levels, and also, of course, UI assets, custom modules, controllers, Mako templates, entirely new apps, blah, 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 blah. So anyway, so just keep that in mind as we progress through these slides. There's search and UI configurations and everything else. So search and UI configurations get automatically replicated across the search head. So if you make a change to a dashboard on one search head, we'll essentially take those on-disk changes and make them happen everywhere else on every other node as well. That doesn't happen instantaneously, but the goal is to make that happen eventually. So if you were to let the system quiesce, eventually everybody would be consistent. But at the moment when you make a change, there is a short time where one node might have one dashboard, another node might not have it. So I'll just walk through a simple example of how this happens. So say as a user, you add a panel to a dashboard. The first part of this process is just like on a standalone search head, a non-clustered one. You essentially, through the client-side JavaScript, submit a request to Splunk. Splunk saves that updated XML to disk, and then subsequent requests that the user makes to Splunk produce that updated XML. So very simple. Nothing too complicated. And that exact same process happens on a cluster search head as well. The kicker with search head clustering is that a background process asynchronously will submit this change that the user made to the captain, the same piece of infrastructure, the same special node that Anirban mentioned, or discussed earlier. And what will happen essentially is the search head cluster member that initially received this change from the user will submit this change up to the captain, who will save the same exact contents to its local storage. And then other search head members in the cluster will periodically fetch changes and apply them locally as well. So the search head captain, or the captain, acts as a central repository for changes made throughout the cluster. And search head cluster members accept changes from users and then pull additional changes that are centralized on the captain. So it's pretty simple, right? It's loosely similar to something like, I don't know, a source control server. People submit changes, and people sync them. Nothing too complicated. Just to walk through a slightly more complicated example, what happens if two people change the same thing at the same time, right? Because in that first example, everything was nice and simple. One user changed one thing, and then no one else did anything while everybody else took their time to sync. So what happens if people are rude? So say one user submits a gray version, the gray version of the dashboard. So say he makes a time chart, he or she makes a time chart, make it gray. Another user modifies that same exact report or the same exact panel, say in a dashboard, makes that time chart blue. So at this moment, at the moment when the two users make this change, the configuration across the search cluster is inconsistent. And depending on which node you go to, you'll see a different visualization. So how do we resolve this? So one of these two nodes will submit the change to the captain first. Let's just say it's the gray one. Then at this point, the captain and the first node with the gray will kind of agree that, hey, this dashboard panel is gray, but the third member will disagree. What will happen is this third member will, like in the previous slide, sync this change, see that this dashboard was modified, but then we'll recognize that, hey, I've modified this same asset. I have an outstanding change against this asset that this other person modified. So essentially, he detects on resolution, he or she detects on resolution that there was a conflict. And the default policy in this system is to prefer one's own change, if that makes sense. So for people who are familiar with source control systems, it's sort of like resolve-AY. So I acknowledge that someone else has changed this thing out from under me. That's okay. I'm just going to make my change on top of that. Just accept whatever I say. So after the node has decided to keep the blue version, retain his or her own version, he or she, that node submits back up to the captain, change gray to blue. So at this point, at this point in the process, the conflict has been resolved. It's as if these two changes did not occur concurrently, right? At this point, I could have told this a totally different story leading up to this point, where gray got disseminated to everybody, and this third node just changed gray to blue. You can't tell that we skipped that gray in the middle anymore. And then from here on, you're kind of home free, right? The first node just pulls the blue change on top of the gray one. Everything's good. You're consistent. So, so there are more complicated examples because there's more operations that can occur than just edit. You can delete things, you can move them around, you can change access controls on nodes. We also try to do our best to have a sane policy where we allow changes to occur concurrently, we allow things to move around but have changes be reflected, and we try to resolve changes in a kind of sane manner, like in this example. And we also log, so you can kind of trace what happened afterwards. Just as somewhat of an aside for if anyone here creates their own apps, app developers often ship custom configurations, can ship custom configurations of their apps to track app-specific states. So you might have an app that, say, pulls events, like a scripted input or a modular input that pulls events from an index. And you might have some custom configuration file that lets you, say, configure the password to talk to your index, or to talk to an external database. And so you can opt in your custom configurations to this automatic replication if you know that merely copying the changes around from node to node is sufficient for your app's purposes. So basically, if your app doesn't do anything special with its conf file other than read the values from them, you can opt in to using this server.conf attribute and say, hey, replicate my changes. So we make it pretty easy to make your app search and clustering aware, at least in the case where your configurations are simple. So just to bring it back, I mentioned earlier that there's two classes of configuration changes, the search and UI related ones, and everything else, the whole slew of other kinds of changes you can make in the system. And only that first type are handled automatically. So what about the other type? The reason that we kind of divided these configurations into two classes is that second class of changes, the slew of all other possible changes in the conf universe, there are many kinds of configurations in that area that are potentially destabilizing. So, for example, you can disable Splunk Web. You can disable the UI process entirely via a configuration file. Web.conf, if anyone is familiar. And so it would be pretty dangerous to allow an administrator to disable the user interface on one node of the cluster and then to automatically replicate that and disable the UI everywhere.
Sorry, go ahead. Go ahead.
Huh? Oh, yeah. So, and there's similar things like, say, changing your authentication mechanism. It would be really scary if someone just turned off LDAP on one node and then all 20 nodes, no one can log in anymore. So we don't replicate those changes mainly for this kind of reason, because a lot of changes that can be made in this domain are more like system administration changes that should have some kind of process around deployment. We wouldn't want to just automatically push button move them around. Unlike, say, like a dashboard, it's easy to roll back. And doesn't generally you can't generally cause an outage just by modifying a dashboard. I guess if you really tried, you probably could. So anyway, so what do we do? So the answer is we use deployment. So this is not the same thing as deployment server or other deployment technologies that exist within the product, but loosely we say we allow for deployment. So the way this works is you pick a node outside of your.
Sorry, I'm seeing. I'm not seeing the presentation.
Oh.
Yeah, go out of full. For some reason, being in full screen seems to bore me. So just
oh, okay. Oh, so we just stay here?
Yeah, it's cool.
Okay.
We're casual. All right.
Okay.
We can still read it.
Okay. So, deployment. Okay. So the idea is you pick one node outside of your circuit cluster. So something that is not a circuit cluster member, and you stage configurations there after you've tested them on your development QA instance, and then you push the changes centrally from that instance out to your search cluster. The reason that you generally pick an instance outside the search cluster is because dynamic captain election tends to move special responsibilities around the cluster. You can't really. You could just pick one member of the search cluster that was not the captain, just always do this from, but generally it's cleaner because the availability requirements around this node are somewhat different. So different people will do different things. You could co-locate it with a deployment server or a distributed management console if you have nodes that are already performing those functions, or you can stand up a new node. But anyway, the idea is these potentially destabilizing system-level changes, you would have a different process around deploying them, and so kind of as a result, the tooling around it, we provide a different workflow. Oh, there's an animation, so I got to full screen it. Oh no! Wait, how do I even do this? Is it this button? Slideshow.
Yeah.
Okay. Does this still work? No. Okay. Well, anyway, there's an animation. I'll just talk to it. So one last thing. This is my last slide. So there's these two categories of configuration changes, right? You can change UI and search stuff, and you can change system-level configuration. So how would a user know? How would an administrator of a Splunk of a search head cluster know, like, what change, like, am I making a system-level change? Like, will this get replicated automatically? It's kind of confusing, right? There's no way for a user to know a priori which category a thing falls into. So we provide guidance around this, some bumpers, by modifying the user interface, like the search clustering. So for anyone, I don't know if people have seen this yet, or if this, I think it's pretty similar to the user interface in 6.1. But basically, there's a menu in the upper right-hand corner of the interface when you're logged in as an administrator. It's a settings drop-down that lets you look at all the things you can modify. And as an admin on a standalone search, you will typically see something like this. So that left-hand column is all, this stuff is kind of the first category of things I was talking about, right? You can change lookup, you can add lookup tables, you can mess with your dashboards and views, you could add save searches. So that's this stuff. Everything else is that second category. Like licensing, for example, you can set a license master and all this kind of stuff. So when you enable circuit clustering, administrators will see a reduced interface. We hide all the UI that corresponds to system-level configurations you should push from the deployer. So that's basically it. We like make sure that by default you can't just click on things that we won't replicate. The escape hatch here is you can click this Show All Settings button and restore the full user interface. If you really know that you want to mess with something, you click this button and it will show a warning. You have to click another thing and it will warn. Anyway, so we'll know that you did it. So, but you can. If you want to debug something, or you're on your testing search cluster, for example, the staging environment, then you can mess with things here. And that's all I have.
Thanks.
Cool.
Right, Eric.
Any questions?
Yeah, any questions from anyone?
If you do have a deployment server, let's say you're running, you want to run one cluster in SF and one in New York. Would that be a reasonable thing to do to control the configuration for a deployment server? Have it done that way?
So this deployer instance kind of provides functionality beyond what you would get with the deployment server, like with the deployment server deployment client infrastructure. Specifically, it handles things like rolling restart, and you can choose how many nodes to restart at once, and so you can bring your cluster back up and down in an orderly way without outage using this tool. So it's somewhat similar to rolling restart for index clustering. So you can use deployment server to manage interactions with this deployment instance, but generally you're going to get a better experience if you have one deployer for every search at cluster, or for every unique set of configurations that you want to deploy. That would generally be the best practice. Yeah.
Thanks very much, guys. Really appreciate you being here.
Great, thank you.
Cool. Take a 5-minute break. Sure. Get a new beer if it's more pizza, and then we'll be back for Clint Sharp going over what's new in 6.2.
Yeah, too much.
Yeah, that's it. I was actually happy to sit through it. There are many things I did not know about search and clustering.
I think we went a little faster than we did it.
Yeah, we went faster, but here we took a little bit time to explain things more.
Yeah. And we're streaming, so a couple people.
So Rachel, we have a Twitter.
Oh, wow. Okay.
Official.
Does it actually say Splunk?
SF Splunk UG. It's very aware that it wouldn't have
No, I'm cool with it, but I had a conversation about it here.
So don't do Splunk Corp or right?
So, no, I asked him, should we have, for instance, a Twitter account for posting jobs? People want Splunk jobs, like tons of them come through. Not just from saying the group all the time. But I thought it was just getting people to know, we want to kind of keep the number of Splunk accounts, Twitter accounts limited.
Sure.
But I would, we just have to get this out.
Yeah, well, I'm generally like a rules don't apply to me kind of person. So.
Yeah. That's fine with me. I would have done it, but I shouldn't have asked. Okay, cool. Yes, I agree. I always act on it.
Because I'm not an employee.
Right.
There's really
What are they
nothing
gonna
I
do to you?
can
I'd be like, I don't know. I can control my customer.
I don't know.
You can fire me as a customer.
Our lawyers like to send nasty letters.
I helped them out with something recently, so they owe me. Seriously, the guy's like, you totally saved my ass.
My lawyers would get you.
Lawyers. Do you want to go back down my desk and pass out? My dad. Yeah. Retired.
Congratulations.
Amazing for that.
One thing led to another.
Did you fly into it?
Yes.
Only for Phoenix, but especially for
Mm.
You know what? There's nothing like
Yeah.
It's so like transatlantic all the way to the west coast is really long flight, right? Is it like more than 10 hours?
Yeah, it's like
Just play with
15 hours. When I first moved here, it was like a really long time to come to.
Is it because the planes are faster now?
Yes. I don't know. But it was a lot longer. It used to be over 10 hours to get to these.
I know on-flight entertainment is something there.
I haven't actually flown commercially since 2010. I take the train.
Oh wow. I've been thinking about trying to take train, but then it
Takes a long time.
takes a long time.
You definitely have to. Oh no, it's done. If I go more than a couple of hours, I get my own little room, so I can take a nap, whatever.
I can decorate it with a calendar.
Actually, I mean, I've been on the same train for up to 55 hours at one stretch, so it's like my room.
Associate trains with the different movies I've seen that, like Before Sunset,
Uh-huh.
right? And then briefcase that like explodes. So romantic.
No, I actually, when you travel by train, you have the opportunity. Room and sit with the people, when you're traveling for work or I'm traveling to get somewhere, I'm not there for the trip, so I just stay in my own room and have the bartender bring me
Wait, what is it?
like flying. I have had on the California Zephyr from Chicago to Reno, I've had really good reviews.
I want to ride that.
Really good.
Wait.
Yeah.
Oh.
But each of their routes has a special like thing that they do, but they change it out sometimes. But that's I've also had a couple of bad experiences, but mostly it's been really good. The breakfast is good. I was getting grits. Grits are really good. I didn't really know about that until I started shopping for
Are grits like a train staple?
I don't know, but they always have them for breakfast if you want them instead of potatoes.
I guess they pack well. You can cook them on a train.
They have a whole dining car that their kitchen is downstairs. And there's also a cafe car, so you can buy. It's like a 7-Eleven type thing where you can buy beer.
Ah, I love the sign. That's awesome.
Intermission. Here we are. All right.
Go Sublime Text. Does anybody pay for Sublime Text? That's an interesting.
I actually just got it on my work computer, so yes. And I did pay for my license.
Like,
I have a person.
I like that it keeps reminding me, and I like that I keep ignoring it. I mean, like, I feel like I should probably pay for it, but I just haven't really gotten around to it yet.
On every third save, you get the warning, right? There's another editor that has Sublime Text 3. change the font to like something terrible like
Oh, you're like,
sand,
I'm
and you
never
can't
ever
change
going
it.
to use
Right?
it again.
Yeah, exactly.
I
But you
see.
can still use it.
All right.
Hefty.
So, one or two people out of the room.
Okay, the coolest part.
I see.
Yes, you want me to share?
I
Yeah.
don't want the 6-1
So-
to do this presentation.
No, I'm not going to do that. I'm going to do the right thing. Let's see. I have too many windows open.
This is Clint, by the way. He's
Hi, I'm
the
Clint.
Director of Product Management at Splunk.
I take the requirements from the customer and I give them to the developers.
That's all you do.
That's all I
No
do.
opinions at all.
No. Okay, let's do the. Yeah, I love this shit. All right.
Great.
Okay. Fine. Okay, fine. Okay. Can people see this on the screen? Yes. Oh yeah. All right. Okay, so if there's anything wrong with this is not my instance. It's Nick Philippe's, so I blame him. We already covered search head clustering. One down. Yeah, but the only thing I put on Twitter is photos. They're good pictures. But
If you want to pick your Pinterest.
yeah, you can follow me on Twitter, Clint Sharp. I put photos on there. Primarily, I only use text-based interfaces to the internet. So if you want to catch me on IRC, I'm Cockix, which is tailbone, and I feel accurately describes my personality.
IRC channel
Pound Splunk on FNet. No, we are not on Freenode because we are not free.
We're not free. We're not an open source platform.
I was a IRC op on Undernet for many years back in the early 90s. Yeah, I was 15. I had nothing better to do than chat with people. Anyway, so Splunk 6.2 features. Awesome. What's most awesome about me doing this presentation is I've done it twice today, and I'm not the PM for any of these features, so I really don't know that much about them, but I am going to represent it like I own it. So, so we already had covered search head clustering. One of the features I am coming to love in 6.2 is the distributed management console, monitoring console. Sorry, it's going to be management eventually. That's 6.3/70/ some future version. Who's wanting to know how much data they're indexing or how much they're searching? I want to know. Yeah. Okay. So we added that. We did that thing. And so if you know Splunk, you know that we log everything about Splunk, sometimes in the ugliest logs you have ever seen that are humanly imaginable. Look in the internal index. I don't know who wrote these log formats, but they're definitely not how we would recommend you log, but don't do what we do what we say to do. We have all this in internal, which is great, except for we gave you absolutely no user interface for finding it. So as long as you like writing searches, then the data is there. But now we provide you a really, really pretty UI. And if you've ever used Splunk on Splunk, this is sort of our productized version, start of a productized version of Splunk on Splunk. So you don't have to download an app, and it is distributed because Splunk clusters are distributed. So in theory, we will gather data from many, many, many of your Splunk servers and bring it to you all together as long as you have deployed a distributed management console, which is now a separate role. So internal to Splunk, we now have multiple roles for servers. They're sort of fuzzy in 6.2, but in future versions they'll be a little bit harder, right? So where you will actually start to assign things, because eventually you're going to want to deploy applications to various things, so we'll have to know what roles particular things are. So what's really cool is, actually I was just talking to the support folks because I had to get a reset key, because even internally we don't give ourselves enough licenses to really experiment with things. So I broke my instance, but I was using the indexing performance screen here to find out when I was indexing data. And so we are indexing no data in this particular test instance, but do you guys know about queues inside of Splunk? There are queues. There are queues for various things that happen, right? So we go through various stages of things that are happening, parsing, merging, typing, etc. So we will show you where in each steps such things are happening so that you can watch it. You can look historically at how much data is being indexed by any given particular source type, which is really handy, because if you find that these aren't 0 and that these are 100 and you want to go figure out why those are 100, it helps to know where the data is coming from. So we provide you that, and we provide you, information on in each of these queues and phases, how full are those particular queues. So if you are a Splunk administrator, you will find this to be incredibly handy. More possibly important, because indexing is rarely the source of your problems unless you're just wondering why the data isn't showing up in a timely fashion. We also provide you a readout on search performance, because this is where you can thank Steven Sorkin. The default is all time, and so when the users first log in to the instance, they will search for all time, and then these dashboards will start to populate with all the really bad searches all of your users are writing that are consuming all of your performance on your cluster. So you can, if people were actually searching in this instance, which they're not because it's Nick's instance and it's a demo, you can get a look at how many particular types of searches are running, scheduled searches, ad hoc searches, but also behind the scenes, as Anirban mentioned earlier, there are data model acceleration searches, there are the report acceleration searches, so there's lots of things that we do in the background on your behalf that are also important for performance, because we do chew up capacity and we don't necessarily tell you about those things. So take a look at that. Very, very cool. There's all sorts of stuff in here and some details on KV Store, which we'll talk about here in a minute. Oh, and I did not mention that the coolest part about this 6.2 overview app is you can download it. So go to Splunk Apps and you can get the 6.2 overview app. So everything I'm showing you here is also included, so you can download it and play with it, etc. So Splunk is pretty damn easy to get data in if you like editing config files. If you don't like editing config files and you want a nice, pretty GUI, then we have tried to make things significantly simpler for you. And so what's the thing you can't fix in Splunk after you index? Event breaking and timestamp extraction. So we want to make sure we really, really, really get this right before unless you're using Hunk, in which case then all that happens at search time, and I will love you for using my product. But the indexing and the event breaking and timestamp extraction all happens ahead of time. So you want to really, really, really make sure that you get such things right. So as you're looking at the add data, we also allow you now to sort of do things from forwarders, but this will get significantly better in future versions. But most importantly, we allow you to get much better previews of the data as you're adding the data and help you break it up into events and then extract timestamps from that in a much prettier sort of UI fashion, and then assign source types, etc. Once you've done this, then if you want to extract fields, then you want to do it for reporting and analytics. I want to have different fields for all of my data. All of that in Splunk is handled at search time. This is what makes Splunk so incredibly unique in the world. For the last 30 years, we had databases, and what do you do with the database? You figure out the structure, then you stuff data in. In Splunk, you stuff data in, then figure out the structure. This is really cool. But the way in which we do this is through regular expressions, and I'm assuming probably since you're a Splunk user group, everybody's going to raise their hand when I ask, do you know how to write a regular expression? Yes, okay. Cool. Well, we try to help you write them as well. Keep in mind, you will always write better regular expressions than the field extractor will write. And if you want to do funny things like do multi-line matches, and you want to ignore case, and you want to do all sorts of other things, then write your own regexes. But if you want the quick, dirty, fast, simple way to do it, in fact, it's easier in some of these cases just to show. So let's go take a look at, for example, indexing. And I'm going to say, like, let's look at weblogs. Weblogs are good. So we've now buried workflow actions under this thing where you have to click in to get to. So if you remember 5.0, they were really easy to get to. Now you have to find them. Come under event actions, you say extract fields. This will take you to our new pretty field extractor. So now, instead of, if you ever use the old one, you'll know you used to paste in values and you say, I want to look at this value, this value, this value, these represent my patterns. Now it's even easier and better. And I actually kind of like it. You just go, I want to say admin, okay, and I'm going to call this username, okay. And then let's look at another field like maybe 200, and let's say this is status, okay, and this is bytes, okay. Now let's go validate the fields. As I go look in each of my fields, it will tell me distributions of these particular values in terms of whether it gets it right. We get this right pretty well. The reason I always show it on weblogs is because we usually get the weblog thing right about 100% of the time. Your mileage may vary on your own particular data types, because automated writing of regexes turns out is kind of a hard problem to solve. But then you can go here and save this, and this will become available to you in your particular app. Now, if you can guess where we're going to save this information inside of the particular UI directory, your guess is probably as good as mine. I can never remember where we're actually going to save these things, but it will be saved and will be usable for other users in the future. Okay. All right, so back to search to show you the other cool. How many people have used the cluster command? See, this is what's bad about SPL, is there's so much awesome shit in SPL that nobody ever finds, right? Because the most important docs page, if you've never been there, is the list of search commands, and you should literally just browse down that and click on every one of them, because there's some really cool shit in there that most people don't bother to actually go learn. Yes?
There's also a really good presentation at Com about this. IRC right now. From Hershey, he did a 10 useful search commands you've probably never used. And all those presentations are now available to anyone from com.splunk.com, so including the audio synced with the slides.
So how many people have log files? All of us. Okay. How many people have ever wanted to find that one thing in the log file that's like the 1 out of a million, but you had to look for the other 999,000 in order to find it, right? This is essentially what cluster does, right? If what I want to be able to do is take a look at this log file and say, okay, there's all these things are happening all the time, and they're generally the exact same thing, right? It's the same log message, but values change in each version. The timestamp changes in each log entry, etc. So as I look through all of these, what I really want is just the sort of unique instances of things in the file, right? Not the things that are changing, but the what we'll call patterns, because marketing came up with a nice name. It's called patterns. So we were actually going to call them clumps. That's what I preferred. I wanted to call them clumps because I thought, because what better thing? What do I want to do with it? What do I want to do with a log file? I want to clump it together, man. I want to figure out what fucking clumps are in my log file, right? So here I'm going to click on the clumps button. In fact, maybe I'll provide some sort of app that modifies the JavaScript to rename it clumps. That's what I should do with my time. That's what I should do with my time. All right. So I click on the clumps button, and when I get the clumps button, I now see unique patterns. And so what's interesting about this is that we are clustering these together, and we use magical math on the back end, and Steve Zhang wrote an algorithm that does these things, so that bring all of this sort of stuff back together into the unique patterns. And so, funny anecdote, I got an email from a sales engineer the other day who was saying, hey, I was trying out the new 6.2 clumps feature. He called it patterns, but I call it clumps. I just, in fact, hold on, let me just pull it up. You guys will love this. So from, what is Jim Don? Here we go. So, not trying to be a Debbie Downer, but you might want to change this before someone demos this by accident, and he shows me the clumps feature here, and the log message says trying to send shit, which was from one of my demo scripts. So, good finding patterns at work, right? People actually use the new features. It's really great. So am I going to change that? No, because it's too funny now. So it's going to be in all the demos. So awesome. All right, so cool. So as you click on these, we'll show you how many events from each particular thing. You can save these as event types, create alerts based off of them. Anyway, I'm a big fan of this feature. It's reasonably scalable. The thing you should know is that the algorithm is fuzzy, so you can tune the how many entries you want versus more entries versus less entries, and it changes how aggressive the algorithm will be in terms of how it does its tokenization and how it goes and looks for these particular patterns, right? So okay, cool. Back to key features. Field extractor, pattern detection, instant pivot. Okay, I'm a command line guy. So I don't particularly use lots of user interfaces, but there are people who don't use command lines. I don't know who they are, but they should all use command lines, but some people don't. So if you don't use command lines, sometimes you might like interfaces like pivot, like in Excel. I want to be able to take my data, and I want to be able to manipulate my data without knowing anything about SPL. So me personally, I would rather just go stats count by blah, blah, blah. But let's just say that maybe I don't want to do the same sort of data. in 6.0, we released a feature called Data Model. And Data Model, same late binding sort of way in which we look at data. So we're still extracting structure at read time, but we want to be able to classify the data and say, this field is an integer, and this field is a date, and this field is a IP address, and this field is a, etc. Once I have that structure, I can do various different things with that. So products like our Enterprise Security Suite, which is in my portfolio, or future IT offerings called like Grayskull, sort of internal project we're building. So these all need that sort of context. But Pivot was our first sort of foray into using that context, that data model context. But we found a lot of people who are Splunk type of people found that sort of creating this data model to be burdensome in order to get access to the Pivot feature. So what we wanted to be able to do, and we made this feature so apparent that you have to click on a tab that nobody ever actually clicks on before there are actual statistics in order to find it. So just note that in order to find this feature, click on the Statistics tab, and under the Statistics tab, there will be a button that says Pivot. And what this allows you to do is pull any search that you have written into the Pivot interface without having to create a data model, right? So I can just take the search and just pop it right into Pivot, and once it's in Pivot, then I can do things like, okay, I want to split this by, let's say, the URI, okay, and we'll add some totals, okay, cool. And then I want to split the columns by, let's say, bytes, and I want to add some totals there. Oh, no, I don't want to split columns, sorry, that would be a bad thing. What I want to do is I want to add another column value. And interestingly enough, because I'm a product manager and I have to do these sorts of things, I was using Excel Pivot last night, and I found it to be incredibly frustrating as compared to our significantly more intuitively than Excel's Pivot interface did. But as you can see, I'm pivoting on the data, right? So I can pull this and create charts and graphs and etc., which leads me to two new features we did add in 6.2, which is you can now do a scatter chart inside of Pivot, and you can do easier scatter charts inside of the regular UI. And we also have a bubble chart. I just don't have the data that feeds a bubble chart. I need another dimension that I don't have in this data. Okay, cool. Instant Pivot. Let's see. Homepage redesign. We redesigned the homepage again. In 2 more versions, we'll probably redesign it again. Just so you know. All right. Oh, I love this feature. Okay, so in terms of features that you'll probably actually use and really like. I search now, and I want to narrow down. It used to be when I clicked on something, it would just add it to my search. The thing that I love about Splunk is that no matter what you click on, it will always probably do the thing you least expect it to do. So in a dashboard, like you would sort of expect it to like maybe highlight the thing that you're clicking on, but instead it'll drill down to search, and then when you try to go back to the dashboard, it will rerun all the searches on the dashboard. And so in this case, we actually are finally doing the thing you would expect us to do, which is give you some options when you click on the thing instead of completely rerun the search on your behalf, right? So this is really nice. So now when I click on something, I can add it to search, exclude it to search, or just run an entirely new search just for this thing. So people are discovering this organically, and like they're giggling like little girls. It's really awesome. They're like, oh my god, this is the greatest feature ever. I can't believe you added this. I've been asking for this forever. And this sort of spawns from the fact that we used to allow you to do this by control clicking or clicking inside the search interface, and then we mysteriously removed it in 6.0 when we rewrote the UI for the 3rd time. And then we never added it back. So now we actually have added a better thing back. No, just click. Just click. Anywhere you click. The negate option is here, exclude, right? Alt click does not work anymore. There's lots of specifics, but we didn't add it back because certain versions of IE, when you control click somewhere, things don't work. Anyway, I don't know. You'd have to ask Devani. She knows the exact reason why.
On any of those selections, is that a new tab that it spawns?
No, it does not spawn a new tab. It will refine your search unless you say new search. I believe if you say new search, I think it just replaces your search.
What about that thing on the right, like the window?
Ah, well, yes, that will actually open it in a new window.
Oh, so you can choose.
Yeah, you can choose.
Oh, and when you re-clicked on something you clicked before, you can take it out.
I just hit back.
No, but like if you click on the 200, does it? Yeah, it like knows.
That you already added it.
Yeah, that you already added it. So.
That's pretty slick. I haven't tried that yet. All right. Yeah, I love that feature.
That is really cool.
Okay, cool. Let's see, what else did... Okay, yeah, so lastly, things that you'll probably care about. Our dashboards are incredibly freaking flexible, and Melting and all the rest of the team spend a shit ton of time trying to make sure the dashboards are really, really featureful. And one of the things we've added in in 6.2 is the ability for me to, so let's say that I want to edit panels. I can now add a panel. I can either clone it from an existing dashboard. I can add pre-built panels. So what I can do is I can take any panel that I built in a dashboard and I can save it as a pre-built panel so that users who come along behind you can take your pre-built panels and put them into your dashboard. So my group inside of Splunk, we build apps. That's what we, well, I have a couple things also in Hunk, which does our Hadoop stuff, but we build apps. And so a lot of what we do in apps is build what we call technology add-ons. And technology add-ons allow us to take data from other sources and map it to like our common information model for use inside of our enterprise security product and others. And so let's say we're building a technology add-on for something like Windows. What we do is we take Windows logs and we say, this is your host name, and host name's always named this name, and your CPU percentage is always named CPU_perk and things of this nature. And so what customers want most from those technology add-ons is actually not necessarily prepackaged dashboards, because those are nice, but what we found customers were doing with the prepackaged dashboards was not ever looking at that dashboard, but just using them as an example of a search you could write, and then going and creating their own dashboard. So now what we're going to be doing, instead of less apps with dashboards and UIs, etc., we're going to build technology add-ons that ship with these pre-built panels. So you're going to install the technology add-on, and then you'll have available pre-built panels that you can then go select and toss into your app. So all of our technology add-ons will come with 4 to 6 pre-built panels with all of the different things. Okay, in terms of 6.2, that's about it. I will plug since I didn't plug any of my own products, I'll talk about one of my products that I'm most proud of, which we just released in August, which is called Splunk App for Stream. And how many people use a network? We all use a network. Okay, cool. And on that network, there's lots of really interesting data that we can collect, right? Every time that I make an HTTP connection, there's data in that HTTP connection that I may want to grab, right? So let's say it's coming from a front-end system to a middleware type system. These are generally really structured data sets, so I can get everything, including full content. I can extract things like metrics data from that. Interesting enough, usually when I demo this on my laptop and I have my own thing, I'm connecting to like Russia and China. I have no idea what the hell I'm connecting to Russia and China, but my laptop is doing things that even I don't know why it's doing or what it's doing. So inside of those connections, both are performance metrics in terms of how long were those connections open, etc. But also there are lots of interesting things in the payload. So from a security context and IT context, etc. So somewhere in an instance, somewhere probably have. Oh, you know what? It's not there. Maybe. Let's see if I have a demo instance. Stream allows you to grab this data, do deep packet inspection on all of your wire data. You can deploy it as an agent. You can deploy it as a Of course, I don't have fail. Anyway, go to Splunk Apps and get it. It allows you to grab all of this wire data, so I can extract key value pairs from all of my HTTP data, all of my DNS data. So, for example, there was a large U.S. retailer recently who had a sort of massive breach relative to your credit card information, and they thought that it might be getting out via DNS. So they went and installed Stream, and they gathered data about all the DNS traffic that was happening, and we logged nice, pretty JSON events into Splunk that show all of the DNS requests that were coming out of their machine. So they put it. You can either put it on network tap, so like maybe you have a full copy of all the packets coming from a network segment, or you can deploy it out to all of your individual forwarders. So whole new class of data, solves lots of really, really interesting problems, and it's on Splunk base, and it's free as in a free puppy. So yeah, the taps are awesome, but also you can put it on everywhere you've got a forwarder, toss it in a deployment server, toss it out, put it on all of your forwarders. That's a great way to gather data as well. And the reason we wanted to make it an agent was because cloud, right? So if you're deploying in Amazon, no one's going to give you a tap in Amazon. So okay, that's last bit for my.
Yeah,
well, that's why I say free is in a free puppy. But we did specifically design the product with that exact problem in mind. So wire data is obviously voluminous. There's lots and lots of connections, lots of metadata about those connections. So we give you several facilities for controlling that. One. Yep, so you can select which fields you want, right? So if the field is useless to you, we won't force you to log it. So every protocol, you can select which fields you want logged for each particular protocol. You can customize each protocol. I can say, for this destination IP and these ports, I want these fields, etc. And lastly, and more importantly, we allow you to pre-aggregate data. So we allow you to say, instead of logging every event, so let's say that you have 1,000 events per second that are hitting this particular web server, you don't necessarily care about logging every individual HTTP connection that's hitting this web server. Maybe what you really want to know is for every source and source IP that's hitting this, which URI did they hit, and what was the give me some aggregated statistics. So we'll allow you to sum up any fields that you select, so you can sum up things like bytes and response time, etc., and we'll give you a count of those events. So you can sum divided by count is your mean, so you can get things like average response time, total bytes transferred, and instead of getting 1,000 events, you'll get one event, right? So this allows you to really, really get pretty fine-grained granular control. As an anecdotal example, we put this on the Splunk network, which taught us really very interesting things about what people do here at Splunk. But we have on an average daily basis, that connection heading center runs about 150 megabits per second, and because it's an